This is Algebra 1, Term 4, Lesson 7, Factors and Products. We'll first look at multiplying and factoring in a Desmos activity. We'll move on to a GeoGebra task. We're going to be relating the graph of a quadratic function with its factors. And then we'll finish up with an application problem, the volume of a box. So let's start in our Desmos classroom activity. So this activity in Desmos will take a while. I would suggest a minimum of an hour, really, to get through it. So I do have this assignment scheduled for 1 or 2 days. It's really more like 1.5 days. So this would be most of your time. There are a total of 20 screens to look at. So let's take a look at the first one. So now we're just getting warmed up, and they're going to be using this model to multiply and factor quadratics. So this is just kind of letting them see it up front. What do you think is going to happen here? The kids that are colorblind will probably not really make as much sense of this, because there is something to do with the color here that's going to model what's happening. I have given you some sample responses and some teacher moves for a lot of these screens, so be sure to check. On this next screen, we're seeing if they remember what product and factor, the vocabulary words, mean. So the first few slides are developing vocabulary as we're introducing this new model for multiplying polynomials and factoring polynomials. So what is a factor? What is a product? How do you tell the difference? They will select all the ones over here that are factors. Then they'll do a match them up with polynomials. Now you'll notice it says right on the screen you have 9 cards and 0 are sorted correctly. It will say 9 are sorted correctly when they get them all. So these are self-checking cards, and this is just a way of teaching them, if they don't already know, the monomial, binomial, and trinomial. Okay, on this one we're going to try to pull in some of that vocabulary, and I've given you quite a bit more. So these are some words I've included in your teacher moves: factor, product, polynomial, trinomial, binomial, sum, simplify, and like terms. So you could throw those up on the board, or just talk about them, or just wait till the kids use them, because here you're asking kids to list vocabulary words that might be used to describe this expression. So some of these terms will come up, hopefully, from your kids. So we want to start with their thinking, and then we can maybe expound upon that. Don't rush through this part. It may seem like, why are we doing this? But if you'll see here, this video is rich. It really has a lot of things going on. So having them take the time to really analyze what they're seeing on the sides of this box model, inside, that trinomial at the bottom, try to solicit that if you can and get them to type in this box what they're noticing. All right, now we're going to get into the meat of the lesson, and most of the screens are similar to this one. So they will type into this box their product. So they are multiplying length times width to get area. You might actually want to say that explicitly. It doesn't say it explicitly here, but it definitely says here product of 2 binomials. So they are multiplying the binomial x plus 6 times the binomial x plus 5, and inside they're going to have 4 terms. And then they're going to use those 4 terms to simplify and get their final product. Now, as they type these in, they do appear in the box, but they also can write over here. So they could write x squared. Just know when they fill in the box, this is going to be kind of covering that up. So they may want to delete their text after they've kind of used this with their thinking. So I say here, use the drawing tools to help with your thinking as needed. They can do that on most of these screens. Or on this one, they're multiplying again using the box model, so they would fill in the 4, and then they would put their final product here. Okay, now this time we have a final product, and that's all we have. So our goal is to figure out what to put on the sides of our box, what factors would go here that would multiply to give us this product. This takes time, and this is one of those screens where I would definitely not jump in quickly. I would let kids guess and check at this point, well, what do we know about the x's? X squared, what's that telling us? What does the 24 tell us? What is the 10x saying? How could we use that to inform our decision? Now, honestly, the only way they're going to notice is for them to actually type some things in, and they've already done some the other way, so let them play for a while here. I would not show them directly any of this if possible. Let them work backwards on their own to find these two factors. And these are pretty simple. Kids already have also learned the relationship between the graphs and the factors. So some of the students are going to be pretty savvy here, and they're going to click on this graphing calculator and put this trinomial in and let that help them. And guess what? That's a great strategy, and that's a good thing if they remember it. So don't discourage that. We're good with that, especially at this point. We're going to try it again with another model. So the difference here is we now have a constant with a negative, and the middle term is positive, so slight difference. Same strategy. Let's see if we can come up with our what goes inside here, and then what factors would give us this. So they can go in any order they want. Give them liberty, because that's really how they learn best, is when they don't go through some rigid sequential step by step process. Playing and fumbling around is actually preferred at this point for them to make sense of what's happening. And then they're going to factor this polynomial. So again, we're doing several in a row that are very similar. Okay, now this one, it says it is special. We actually call these special products. Okay, so what's going on here? So let's see if they can figure out what's pattern. Now again, your colorblind kids probably have no clue what this is supposed to be doing, because they can't tell the shades or the colors. So you may have to have some conversations with them, or just excuse them from this slide, because the poor things are not catching what this is. I wish there was another way to do this one, that you could draw it in a different way for them to see it. Maybe put hash marks going this way, and then make hash marks go this way, and then make them overlap there. I don't know. Maybe use dots and patterns instead of colors. Here's another one that's a special product. We're multiplying x plus 3 times x plus 3. What would go in this? You don't do anything differently. You're still just multiplying the two factors to get your product, and then you're simplifying to get your final product here. But it's special because our factors just happen to match. I have not given them an example of the binomial with the squared yet. That is coming in a future lesson. That will not be addressed in this particular lesson. Here we have another trinomial. Let's see if we can work backwards. And then here's another one. Okay, so what happened is these disappeared. Now hopefully even our colorblind kids can see that something happened where those two are no longer there. So there's nothing in these spaces. Why is this happening? What do you think is happening? So I think pretty much all the kids could make sense of this one, maybe. We'll see. But let them discuss it. They need to type something in that box and share with the class. And then this one is telling them, if they didn't already notice it, something's disappearing. So as they do their product, they should notice that the middle term is gone, because the x terms added up to 0 inside their box. And here we're going to go in reverse. Where does the x squared go? Where does the minus 81 go? And what do we know about our middle terms? Well, we know they add up to 0. So what would they need to be? And so let them play with that. Here they're putting their factors. Now we're going to get into, I love this. This is such a fantastic model. Kurt Salisbury from Texas made this, and I didn't make a lot of this, but I did tweak a lot of this, and this is fascinating. And what he had to do to make this, I still haven't figured out how he did it, but he did a great job. So you can create two binomials. See, and they've got their binomials here, and then you've got your factors. So now they're seeing a relationship between the graph and the factors. Now I'm not going to give you this particular answer. I want you to do that, or for them to do that, but let's see if they can make sense of creating this trinomial using this model. And then these factors should reveal something. So if the kids that have already been using their calculators to help themselves will be completely finished with this before you can even show them because they know it already. But some of the kids may have all forgotten, we do have graphs to help with this. So they'll do the same here. We have a trinomial. We're going to create a model with our box and with our graph, make it fit, and then one more. So they have 3 in a row that are pretty similar here. So here we have a card sort, 4 sets of 3 cards. It is self-checking, and this is a great way for students to make sense of all the things that they've done so far. This is one screen where we put it all together. And then finally, they're going to create their own. Now, I haven't given them a lot lately that they could use in a portfolio, and we do need to get busy on that because we need to do our portfolio for the second semester. So this here is an example of something that would be great for a portfolio. They're going to create their own quadratic function. They can start with their factors and then fill in their box and then come up with a trinomial for that. Or it may not even be a trinomial, but it says complete an equation with a simplified product. So whatever's inside this box will be simplified, and they'll just type that here. They do need to identify the zeros, explain how the zeros and the factors are related. They're actually sketching the graph. I would suggest they work to get their vertex, their x-intercepts, and their y-intercepts well, and then the rest of the points, tell them not to stress out if they can't get the curve to look just right, because you are freehanding and that's hard to do. It's quite hard to do and make it look really nice. If they were doing this for a portfolio, it might be smart for them to actually create their graph in Desmos and insert that and maybe, screen capture this box and put that in their artifact so they could make it look even better if they're inserting it into a portfolio artifact. But that's all there is in this activity. This does take time, especially if you're going to give them plenty of time to guess and check and to make these connections for themselves. They do have to sleep on this. This is not something they really should learn in one day. So having this spill over into day 2 is kind of preferred. So I would not rush to try to finish everything in one day. Let this one spill over so that they have time to sleep, make those connections, and come back to it the second day. So let's move over to our slides and we'll look at some problems in GeoGebra. So the first task in GeoGebra, we're going to go to this link and we're going to see at the top a trinomial, and it says factor f of x to form x plus d and x plus p. So you're changing d and p, which are these two numbers, to fit this one. Now, I'm going to go ahead and do one. It's unlikely they're going to get this same one anyway because there's a whole bunch in here. So let's go ahead and say 60. Well, maybe D could be 6. And then P would have to be 10 to get 60. And then D times, or 10 plus 6 is 16. So this one worked great. You'll notice the blue dash appears. So as soon as they get that, the score does not change. And I didn't really ask about the score anyway, so I don't know that that's so important. But what will happen is when they click for new data, it'll take that off. So have them take a picture first of this, screen capture that, drop it on the slide, and then when they click new data, see, that will go away and a new appears. So they'll do it again. Tell them be careful, don't click new data till you get your screenshot. So they're going to place the screenshot here, go to the second screen, do it again. Place their screenshot here, go to the second screen, do it again. Now they do say do this 10 times. I don't want them to do it 10 times. I want them to do 5. So they need 5 correct, or actually 4. I only did 4 this time. So GeoGebra task 1 through 4, it goes pretty quickly. I do have some guided questions, so let's take a look at those. So the first guiding question I gave them was on screen 2, on slide 2. How do the numbers in the factors relate to the last term of the trinomial? So they will have a trinomial. What's that last number, and where do you see that in your factors? Now the factors are in green. So the factors here were in green, 6 and 10. And so how did those relate? This was a 60. How did those relate? 6 times 10. So we want them to notice these things. If they're not already, this will help them maybe notice that. And then this one, I'm asking, how do the factors relate to the middle term of the trinomial? So the middle term is the one with the x in the middle, and I'll just let them answer that. I don't ask them any questions on the next 2 screens. I'm just telling them to go full screen, so if they need to see it better. All right, let's finish up with our last task. Okay, our final task. This can be independent, it could be partners, and it could be teams at their desks. Since I've been going to the board quite a bit, I probably would let them work at their desk on this one. It just kind of depends on what's going on at that time, but I'm going to have the kids create for me an equation for the length of this box in terms of the width. And what I'm told here is the perimeter of the base is 24 inches. Notice the 4 inches has to do with the height of the box, so it really has nothing to do at all with this question or this equation. So they will not need to use it. They are also asked for the domain in this context. So what are possible values for x? And also get into the types of numbers that we can use for x in this context. So good review of linear functions, domain, writing equations of linear functions. Okay, now we're going to extend that to the volume. Now they may or may not remember the volume, but most should have had exposure to it prior to your class. It is the length times the width times the height of this box. So basically 4 times x times y. Now they can't use y in their function. They have to change that to some expression with x, and they've just written an equation for the length in terms of x. So they will use that expression in their equation for their volume. Now here's the thing, they shouldn't multiply this out immediately, but they should multiply it out, because if you look at your notes, and I'm going to go ahead and get out of here so you can see these notes, I do want them to multiply with the distributive property to create a second form of this equation and insert images of 2 equations for this volume. So one of the equations will be in factored form, but the other equation should be in standard form. We haven't named it yet, and we will name it when we get to a future lesson, but I do want to see 2 different equations here. And then what are the zeros of this function, and what do they reveal in this context? So what's happening with the box if x is 0, if y is 0? Well, if x is 0, that's not a 0 of the function, that's actually a y-intercept, but I think maybe the 0 and the y-intercept are one and the same, at least for one of these. So let's go ahead and look at the last screen. Now once they've created this function, they can use either one to graph and analyze for the next slide. Here we're typing in the volume as a function of x into the Desmos calculator and graphing. We should get a parabola, and they should make the graph look good. In other words, they should be able to see their x-intercepts. They should be able to see their vertex. They should restrict the domain of their graph to fit the context. They should have the appropriate labels and scales on their graph. It shouldn't be a skinny parabola, as we've talked about in the past. It should look nice. So this may take a little time for some students, but this is something they do independently need to be working on for these. This is not really a team task, except to maybe talk to one another and assist one another as needed. But I would say this needs to be done by individual students. And then I'm asking, what is the vertex, and what does the vertex reveal in this context? So there are 2 numbers. What do each one give you in this context? This is reviewing lots of concepts and lots of topics, all of which are super important when it comes to the use of quadratic functions. And this concludes our factors and products lesson. Next time we'll be doing sidewalk chalk, and that's going to be great fun. Y'all have a great day.